This video is going to cover surface area of prisms and pyramids. This is in addition to chapter 11. So it's a supplement to our textbook. It's not in our textbook. So first we're going to talk about lateral area and surface area. First we're going to define what lateral area is. Lateral area is the sum of the areas of the lateral faces. So it's going to be all of the side faces, but not the base. So it's not going to be a base area. So all side polygons, all sides, not the base. So in the case of a prism, there'll be two, and in the case of a pyramid, there will be one base. The surface area, or you might also see it called total area, these will be used interchangeably, is going to be the sum of all of its faces, the lateral area plus the base area. So again, surface area is the same thing as total area. So if you see a question where they ask you to find the surface area of the solid or total area, it means the same thing. So we can either abbreviate this as SA or TA. So to calculate the surface area, when we're talking about a pyramid, so surface area or total area of a pyramid, the way that we'll find that is we're going to take the lateral area, we'll find that, the area of all of the sides, or all the lateral faces, plus the area of the base. When we're talking about the surface area or the total area of a prism, we'll find that by finding the lateral areas, and then we'll add that to the two base areas. So this would be the surface area or the total area for a prism. So let's first talk about prisms. So again, the lateral area could either be found by finding the perimeter and multiplying the perimeter of the base and then multiplying it by the height. Remember that lateral area does not, so this does not include the area of the base. So this does not include the area of the base. So for example, we have some pictures of some prisms here. But before we talk about them, let's also talk about the formula for total area. So again, total area or surface area can be found by finding the lateral area first and then adding it to the two base areas, where the capital B represents the area of the base. So again, remember lateral area is perimeter times height. So that would be another formula that we could use, or just multiply perimeter times height. So total area would be the area of every single face of our prism. So again, what we're doing here to get total area is we're going to be doing the base areas, and there's always two of them. Whenever figure you have two of, that is your base areas, and then plus the areas of all the lateral faces, and that gives us total area. So let's go back and take a look at our figures here. So up top here, this is a rectangular prism. When you have a rectangular prism, here it doesn't matter which two rectangles you choose and call them your bases. You can either do the top and the bottom, the front and the back, or the left side and the right side. And then after that, the other rectangles will be the lateral faces. So here we could say the top and the bottom could be your bases, and then the left, the right, the front, and the back would be the lateral faces. This figure over here, this is actually a triangular prism. Notice we have 2 triangle faces, and then we have 3 rectangle faces, or 3 parallelogram faces. So the base here would be what we have 2 of, and it would be the triangles. Again, back from section 11.5, remember to name a prism. The shape of the base gives the name of the type of prism you have. And then this last picture here, again, the figure that we have 2 of, we have 2 hexagons. So this would be a hexagonal prism. So again, we have 2 hexagons, which are our base shapes, and then we have 6 rectangles or parallelograms. So let's take a look at our first example. It's asking us to complete the table. Now I'm actually going to also add one more box here. We're going to add the surface area, or call this total area. So let's identify what the P, the B, the LA, the SA, and the TA all stand for. So here, the P represents the area, the perimeter of the base. So this is the perimeter of the base. The B, the capital B, represents the area of the base. The LA, this represents the lateral area. The TA, or the SA, this represents the total area or surface area. So let's go through and identify the formulas. So for perimeter, we're just going to add all the sides. In this particular prism, the shape that's on our base is going to be a rectangle. So that will either be, that'll be base times height. And for your lateral area, we're going to find the perimeter of the base and multiply it by the height of the prism. And then for total area, we'll find the lateral area, and then we'll add that to the 2 base areas. So let's go ahead. And again, it's a rectangular prism. So technically I could choose whatever I want to be my base here, but I am going to use the top and the bottom. So like if I showed this here, I could see this is 2, this is 4. So if I go to find the perimeter of my base, I'm going to add 4 plus 4 plus 2 plus 2, giving me a total perimeter of 12 centimeters. Remember to find the area of the base. Again, this is a rectangle, so it's base times height. So I'll do 4 times 2, and it's 8 centimeters squared. For lateral area, we're going to take the perimeter and we're going to multiply it by the height. So my perimeter, I already calculated that in the first box. That's 12. And my height is going to be the 6 over here, the height of the prism. So 12 times 6, and my lateral area is going to be 72 centimeters squared. And lastly, for the surface area, the total area, again, remember we're going to take the lateral area, which we already calculated, and then add that to the two base areas. So my lateral area is going to be 72. My two base areas were 8, and I have 2 of them. 72 plus 16, giving me 88 centimeters squared. Now, remember, for this one, we could have also done 2 times the base, and if we didn't have the lateral area already calculated, remember, lateral area is perimeter times height. So again, we could do 2 times 8 plus the perimeter was 12 times the height, which was 6, and again do 16 plus 72, again giving me the same number, 88 centimeters squared. Okay, for our next example, we have an example of a triangular prism. Notice the shape that's on the top and the bottom of our figure is a triangle. So we have a triangle down here and up here. Both bases are congruent triangles. So whatever side length I don't have in one triangle, I could move it to the other. So this side is also 3, this one's 4, and from the one in the top, I can also say this one's also 4. And then I can also see the height from the other triangle. So the first thing, so this again is a triangular prism. The shape that is on the top and the bottom here is a triangle, and that's how your prism is named, by the shape of the base. So again, just to recap what I said from the previous slide, we know that the P is going to represent, we're going to be looking for the perimeter of the base. The capital B represents the area of the base. And in this case, it's a triangle, so it's going to be the 1/2 base times height, formula for area of a triangle. And then the LA represents the lateral area. And again, that's perimeter times height. And again, I'm going to add another box, or another row here. And in here, I'm going to put surface area or total area. And again, SA/TA, that represents surface area or total area of my triangular prism. And that formula, because it's a prism and there are 2 bases, so 2 times the base area plus the lateral area, and or you could memorize it as 2 times the base area plus perimeter times height. So let's go through and we're going to figure out each one of these rows. Let's fill it in. So again, for perimeter, remember you're going to add up all the sides. So the 3 sides of my triangular base, it has a side of 3, 4, and 4. So 3 plus 4 plus 4 is 11 centimeters. The area of the base, again, it is a triangle in this shape. So 1/2 base times height. So 1/2, and my base is 4. And you can see the height over here. It's the 2.8. Let me, not right on top of it. So here is the height. So 4 times 2.8, and then divide that by 2 or multiply it by 1/2. I could, if I wasn't using a calculator, I could take 1/2 of 4 is 2. 2 times 2.8, and my area of my base is 5.6 centimeters squared. For the lateral area, remember that is perimeter times height. You can see the height of my prism is over here, it's the 6. So I calculated the perimeter up here, it was 11. So I'm going to do 11 times the height, which is 6. So 11 times 6. So the lateral area is 66 centimeters squared. And for total area, we're going to do 2 times the base area plus the lateral area. So we calculated the B in the second row there, and that was 2 times 5.6 plus the lateral area, which was in the row right above, which was 66. And 2 times 5.6 is 11.2 plus 66, giving me a total area of 77.2 centimeters squared. And that would go in that box. My third example, notice the shape that I have 2 of. I have 2 hexagons. This time my shape is not sitting on its base. The base is on the side. So this is a hexagonal prism. So, hexagonal. This time it's not asking me to find each of the different pieces separately. It's only asking for total area. So for the total area, I'm going to find the area of the base, and there's 2 of them, and then I'm going to add the lateral area, which is perimeter times height. So let's go ahead, and in order to find the area of my base, which is a hexagon, my base is a hexagon, and if you recall the formula to find an area of a hexagon, it was 1/2 apothem times number of sides times side length. In my picture, I have all of the variables. I have values for all of those 3 variables. My apothem is 7. It's right here in this red. My number of sides, it's a hexagon, so it's got 6 sides. And the side length is the 8 over here. So I can find the area of the base. So 1/2 times 7 times 6 times 8. Doesn't matter the order I multiply. I could find half of 8, make it 4. Multiply 7 times 6, 42, times 4. And my base area is 168. Notice my numbers do not have numbers on them, so this would be units squared. So far in my formula, I've calculated capital B. So 2 times the base area, which is 168. I don't know the perimeter yet, so let's go ahead and find the perimeter of my hexagon. And I know that there are 6 sides. Remember, the formula for perimeter is the number of sides in your figure times the side length. I know that there are 6 sides, and I know each side length is 8. So the perimeter of my figure is 48 units. So now I'm going to go ahead and put 48 over here. The height of my prism is this 6. This is the height. So 48 times 6. So now let me multiply. 2 times 168 gives me 336. 48 times 6 gives me 288. I'm going to add those 2. This should be a 6. I'm going to add the two numbers, and I get 624 units squared. And this is the total area of my hexagonal prism. Next, work with some pyramid examples. But first, let's go through, and again, we need to figure out what we need to do to find the lateral area. So there's two methods when we're trying to find the lateral area of a regular pyramid with n lateral faces. Now, these two methods are only for regular pyramids. So in the figure here, this would be an example of a square pyramid. Remember, a regular polygon means that we have congruent sides and all congruent angles. So all sides are congruent and all angles are congruent when we say that our polygon is regular. We could also have a regular triangular pyramid, and that would be an equilateral triangle that would serve as our base. So there's two methods. The first one is to find the area of one lateral face and then multiply it by n, which is the number of lateral faces you have. So in this particular example here, there would be 4 lateral faces that would all be congruent. The second method is to use the formula 1/2 PL, where P represents the perimeter, and the lowercase l here, this is our slant height. So you could do either method. So the first method, in this case, if we were to do method 1, we would be finding the area of one of the triangles, which is 1/2 base times height. And in this figure, since it's a square pyramid, we would times that total by 4. So however many lateral faces you have up at the top, that would be the value of n. Now for total area of a pyramid, this time we only have one base, and then we would find the lateral area, and we could use the formula 1/2 perimeter times slant height. Okay, or just remember, total area, another name for it, they might suggest it as, or ask it as, find the surface area. So again, basically what we're doing is finding the area of the base, there will only be one, and then we're adding all of the lateral areas. And again, remember from the previous slide, to find lateral area, we would find the area of one of the triangles and then multiply it by the number of triangles you have. Or you can do 1/2 perimeter times slant height. Either way. Now, this formula here that we just talked about, this is only when your figure is regular. If you have a pyramid that is not regular, for example, a rectangular pyramid, then what we would have to do is find the area of all the faces separately and then add them together. So if you have a rectangular pyramid, that would be the steps that we would take. We would find the areas of each of the faces separately and add them up. So let's first try to find the area of a regular pyramid. And notice it's a regular square pyramid. And it's giving us that it has a base edge of 6 centimeters and a lateral edge of 5 centimeters. Now notice a picture was not provided. So be able to draw a picture if only a description of the figure is given. So when I try to draw a picture of a pyramid, I'm going to start by first drawing a triangle. And then I'm going to extend and make a side here and draw another triangle. And now what I'm going to do is show the sides that are like in the back that you can't see, and I'm going to represent those as dashed lines. And then now you can sort of see the square that's on the bottom of my figure. So again, it told me it had a base edge of 6 centimeters. So I know that all of these sides here, even the dashed one underneath, all of these sides are 6. And then it's telling me it has a lateral edge of 5 centimeters. So the lateral edge, these are the sides going down here. Now the pyramids are a little tricky because we've got slant heights, we've got the actual height of the pyramid, we've got a lateral edge, a base edge. It's got quite a few different things that we need to label in our picture. All right, so all I've done so far is drawn the picture and label my given information. I now need to start answering the questions. The first question they're asking me to find, or the first thing, is the slant height. And my slant height, I'm going to draw it. It can either come straight down here, and it'll form a right angle. There could also be one here. All of the lateral faces have a slant height. So in order to find this, I'm going to pull out the triangle that's here. So I'm going to pull this slant height down here, and then I can draw down this lateral side. Actually, let me draw the lateral edge in yellow, and that's 5. And then this piece that's right here. Now, by drawing down the lateral height here, or the slant height, notice this was originally an equilateral triangle. Here's a 5 and a 5, and now I've just split it this 6, and now this is 3 and 3. So I have a 3 here, and now I need to find the slant height. And if you remember your triples, this is actually a Pythagorean triple, and my slant height is going to be 4 centimeters. But let's say you didn't remember your triples, so we could have said this is x. So I would have done x squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. Subtract the 9. X squared equals 16. Square root it, and my slant height is 4. The next thing is asking me to find the lateral area. Well, I can see that I have 4 triangles up at the top, so I can go ahead and I could do 1/2 base times height, and because it wants the total lateral area, all 4 triangles, once I find that area of one of the triangles, I'll multiply it by 4. So I just found the height of the triangle. So my base is 6. My height is 4. So 1/2, 6 times 4 times 4, because there's 4 of them, gives me 48. So my lateral area is 48 centimeters squared. Now, keep in mind, we could have also found the lateral area by using the formula 1/2 P perimeter times slant height. So the perimeter, because the perimeter of my base is a square, I know that each side of my square was 6. So 6 times 4 is 24. And my slant height is 4. So then now I can just multiply. I could take half of the 24, 12 times 4, and I get 48. So either way, either use this formula, the 1/2 perimeter times slant height, or find the area of one of the triangles and then multiply it by however many triangles you have and in this case, we have 4. Next, we need to find the base area. Again, my base of my pyramid is a square. So I just need to do base times height, or side squared. So my base area is a square, so 6 times 6, and it's 36 centimeters squared. For the total area, we're going to do, and I'll do it down here, total area is equal to the area of the base plus the lateral area. Well, I just did the base area. It was 36. My lateral area is 48. I'll add those two, and I get 84 centimeters squared. Next, it wants me to find the length of the altitude. Well, my altitude, this is actually the height of my pyramid. And the pyramid's height, or the altitude, goes from that top vertex to the center of the base. So what we need to do is draw a right triangle inside here. So if I open this up, so it's going to go to the center of the base to the top. And then what I'll do is I'm going to draw a right triangle. So if you know that it's the center, I know this side is 3, and then I can use my slant height, which was 4, for the hypotenuse. So let's go ahead and draw this outside. Let me pull it out. This is 3, this is 4. Now, at first glance, you might think, oh, wait a minute, that's a triple. However, the 4 is the hypotenuse. So we could call this the altitude, we'll call it A. So A squared plus 3 squared equals 4 squared. A squared plus 9 equals 16. Subtract the 9. A squared equals 7. Square root it, and my altitude is the square root of 7. So the length of the altitude is the square root of 7. Let's try another regular example. This time we have a regular triangular pyramid. So this tells me that my base shape here is going to be an equilateral triangle. And again, I've got 3 parts that I need to look for. They want me to find the lateral area, the base area, and the total area. Let's go ahead and label our figure based on our given information. This time they're giving me the slant height. So my slant height again goes here and down the side of the triangle. And this is 9. It's giving me my total base perimeter. So my base again, remember, is this equilateral triangle, 60, 60, 60. If the entire perimeter is 12, if I know that I have 3 sides in my triangle, I can divide it by 3, and that's going to give me the length of each side, which is going to be 4. So 4, 4, and 4 will go here. So now what I need to do is I need to first find the lateral area, and I can use the formula 1/2 perimeter times slant height. So they gave me both of these in my given, so it's 1/2 12, which was the perimeter, and the slant height was 9. I could take half of 12, make it 6. So my lateral area is 54 centimeters squared. Now for the base area, I need to figure out the height. So for the base area, it's a triangle, so I need to do 1/2 base times height. I know the length of the base, it's 4, but I don't know the height. So let me work on finding the height of my base triangle. Notice once I split my equilateral triangle, now each one of these angles are 30. So now I've just created two 30, 60, 90 triangles. So let me work with one side. So, and I'll keep it upside down like it's there. So now this is 30, this one's 60, and here's the right angle. I know the hypotenuse is 4, and remember in your 30, 60, 90, this would be like 2x, across from 30 is x, and across from the 60 is x root 3. So if I've split my 4 into 2 and 2, that's 2, so this would be 2 root 3. So the height of my triangle is 2 root 3. Once I multiply 1/2 times 4 times 2 root 3, I could take half of the 4, and then 2 times 2 is 4, square root 3. And that would be the area of the base, and again, centimeters squared. And now lastly, for total area, remember total area is the area of the base plus the lateral area. So I found the area of the base in part B, and that's 4 square root 3. I found the lateral area in part A, and that was 54. If you are not using a calculator, you would leave your answer just like this. If we were using our calculator, we would figure out what the square root of 3 is, multiply it by 4, and then add 54. So if they ask you to give it in decimal form, you would do it on your calculator, round it to the tenths place, 60.9 centimeters squared. So this would be with a calculator, and this would be without. So be able to do it both ways. We have one more example. This is an example of a rectangular prism pyramid, and here we can't use the formula. So we would have to find all of the faces separately, all their areas, and then add them up. So again, you can see that the bottom is a rectangle. It's an 11 by 5. So this would be a rectangular pyramid. And in order to find its total area, which is what they're asking for, total area, I'm going to find the area of the base. I'm going to add it to the area of the front triangle. I'm going to add it to the area of the back triangle. I'm going to add it to the area of the left triangle. And then lastly, add it to the area of the right triangle. Now, both the left and the right triangle, these are the same. So once I find one, I can just double it. And then the same for the front and the back. These will be congruent triangles. So let's go through and let's start filling this in. So again, to find total area, I'm going to find the area of the base. So my base is a rectangle, so 11 times 5, and that's 55. Then I'm going to find the area of the front. So I could say I have this triangle here. And its base is 11, and its height is 10.3. So I'm going to do 1/2 base, which is 11, times the height, which is 10.3. This is also going to be the same formula for the back. So 1/2, 11 times 10.3. And then now I'll do the triangle on the left side and the right side. Over here. You can see it has a base of 5 and a height of 11.4. So 1/2, 5 times 11.4. That would be for the left. Same for the right. 1/2, 5 times 11.4. So let me go ahead and multiply these. So the 1/2, 11 times 10.3 gives me 56.65. It's the same for the back. Then the left, 1/2, 5 times 11.4 gives me 28.5, which is the same as the right. Now I'll go back and add these 5 numbers, and I get 225.3 yards squared. So when your figure is not a regular shape as the base, meaning if it's not a square or an equilateral triangle, then you would have to find each of the faces separately and add them up. But in the case of the rectangle, the front and back triangles will be the same, and the left and right. So let me just add a slide here and let me recap formulas that we covered today. So we talked about prisms. So to find the lateral area, we're going to find the perimeter and multiply it by the height. To find total area or surface area, so total area or surface area, we're going to find the area of the base, and there will be 2, and add either the lateral area or, if you're not going to calculate the lateral area ahead of time and you know the perimeter and the height, you can also use that formula. Now we're going to write down the 2 formulas for pyramids. And these are only regular pyramids. So again, the lateral area, LA, is going to be 1/2 perimeter times slant height. Remember, P stands for perimeter and L stands for slant height. And then for the total area or the surface area, this time there's only 1 base. We'll add the lateral area, or again, you can do 1/2 perimeter times slant height. So what you need to do now is work on completing these notes. Once your notes are completed, you're going to submit them to Canvas, and then after that, you can start working on the worksheet. And again, remember the homework is a combination of section 11.5 and the notes that we just covered, the surface area of both prisms and pyramids.